Imagine what happens when you give every team in your company the power to ship their own data products, and what happens if those data products are autonomous. Scale happens. Suddenly, your data product work isn't stuck. They're happening everywhere at once. They move at the speed of your business, not behind it. Imagine you're a retail company, Nextopia.co. Each team, marketing, merchandise, supply chain, sales, they're not waiting for a central data team. They are building and shipping their own data products, fast, self-serve, and safe. Each team is in control of their own destiny, and that's how scale becomes real. Each of these hexagons you see, that's an autonomous data product. Each data product is fully responsible for its own data, from generation to governance to discovery, with full control on its own unique data stack. Take this one, for example, multi-channel sales. It provisions its own cloud infrastructure, runs its analysis on Databricks compute, stores output in Azure Blob with Delta file format, and pushes it to Snowflake 2. And it gets its data from S3 on AWS on a completely different cloud, all in one unified data product. It runs its own contracts and controls and emits real-time signals about its health. It generates data on a cadence that makes sense to it, in this case, every few minutes. It manages access to its consumers, and it defines its own semantic models. In this case, 3 different models, and delivers data for the same semantic in different formats. And here's the best part. We don't have to worry about 3 or 4 or 5 different tools, pipelines, semantic layers, governance, access, observability. It's all here, wrapped into one autonomous data product. It's simple and scalable. And it's not just pipelines, it's semantics too. For each data product, it defines its own semantic relationships and is with its adjacent nodes. For example, multi-channel product comes from the product catalog. Region is aligned with where the product was actually sold. So what do we get? A living semantic graph built from the bottom up, always in sync with the data it describes. No more top-down semantic layers that go stale the moment you build them. This is semantic at scale, emergent and alive. Now let's talk about what it's like to be a data producer with Nextdata. Take multi-channel sales, for example. The team wrote some business logic in Python, calculating trending and emerging products, and checked it into Git. Great practice. That's it for the core logic. Now, to turn it into a fully autonomous data product, here is all they need to do. Declare the data product details, name, descriptions, and its purpose. Specify its input and the contractual expectations, what semantic model it expects, what should happen if they're not met, fail hard or warn and continue. Define its outputs, what it produces and the guarantees it makes, and add a few controls. In this case, who can discover the product and access its data, and how long the data should be retained. And that's it. What you just saw was a Python-based specification, but you could use YAML, SQL, or even auto-generate these from your existing assets. You pass it to Nextdata OS and launch your data product. It provisions its own infrastructure, Databricks, Snowflake, ADLS, whatever it needs, automatically. It listens for data changes on its inputs. It validates them, runs the logic, produces the semantic in multiple data formats for multiple use cases, only produces the data it promised, it protects itself from bad access, and while doing all of that, gives you real-time information about its metrics and health. No more waiting for infra, no more duct taping tools for quality, contracts, metadata, orchestration, no more duct taping, period. Leave that to us. Just one powerful unified experience, an autonomous data product up and running. So let's go and use Nextdata AI, our multi-agent system, to build a data product for us around the financial performance of these companies. Nextdata AI interacts with us in a hybrid mode. You can see now all the elements that constitute a working data product presented here. Their models, input, outputs, promises, policies, control, and you can either work in prompt or you can interact with the screen and get guided what you need to build. The guide includes semantic models, inputs, outputs. We can start anywhere we want, but as a semantic first, I want to start with the semantic. So to capture, to get the semantic in, I want to start with looking at the source data. This is a financial statements as we get these as files or as file dumps or sources of APIs from upstream. And we sometimes purchase these, or sometimes we go to SEC API to get these SEC filings. So in this case, I can pass a URL. I don't have to really say what format it is. It can infer that. So I'm going to provide a URL for getting access to the source data so that we can process it and get the relevant information about the competitor out and start the process. So the process starts. I have provided now the URL to an API endpoint where we can fetch this information. And next, what is next to doing is really fetching data, sample data from that URL. It needs some credentials. So I have access, and my user has access to a certain API services. And I have provided the API service to SEC endpoint, which has all the credentials and details behind it. To get access to it is fetching the data, and it's analyzing the data, and it's looking at the web, looking at what we have already on the mesh, what domains we have, what data products we have, what semantic those have. And it's now inferred 3 different models in that. It has inferred that there are balance sheets. These are simple, relatively simple models. But balance sheet information about the competitors. It has found cash flow statements, and it also has the collection of the documents that point to the actual document types and extracted some metadata about those documents. As a default operation, it has now created an output for analysts. So by default, knowing what infrastructure I have, my user has access to, it has selected Snowflake to produce this data as tables on a more tabular output. And it has created some promises, some contracts that they will always assure that this data product will provide the balance sheet and cash flow based on those storage agnostic structure of the data that we decide. And it's getting the data from this input, which is an API input. On the left-hand side, you can see that it's making some recommendations and say, hey, I'm seeing a column that is not really semantically relevant. This column 0, maybe we should just, it was an index that came from, a previous system. It's relevant, let's drop that. That's not part of the semantic. It's making some recommendations around some constraints and rules to put on the semantic model. It has decided that maybe hourly trigger to receive this data is fine, and has, as I said, it has decided to put this on Snowflake. And I'm going to confirm these suggestions. Of course, I can go back and challenge and say, do different things. But I'm going to just confirm the recommendation that it has made, and let's see what's going to happen. Once it's confirmed, you can see that it starts now inferring the name. So from the name being SEC competitor summary. I'm not in love with the name, to be honest, but it's good enough, and it has a reasonable description that it has inferred, again, from the data that it has seen and the other information about the mesh it has. And it has also if you look at the top, it yeah, it actually dropped the columns as well. And it's decided that it should belong to finance domain. Well, that's a good start. It didn't decide that it should define onto retail domain or risk domain. So it has made some good first choices. And it also dropped, as I said, if you look at the columns, the fields on the right-hand side is defined. Let's change the name. This is really about financial statements, the balance sheets and cash flow. That we can change it to. And while the finance is pretty good, I want to change the domain as well. I want to change the domain to be a subdomain within finance. So finance, financial performance, let's say. So we make the change. I can change it in UI, or I can change it in prompt. This is a hybrid experience, and whichever experience is more relevant for that function, the user can decide to do that. So now the metadata is updated, and let's look at it. Yep, the domain has changed. We are, I think we are good to go. Let's launch the data product. So again, I had an option of clicking on a button on the bottom right-hand side, but I just for the show and the demo, I'm talking to the agent and asking to launch. So what is happening during the launch? This data product is a process. It's going behind the scene. Here we go. It's up. What it did was it went behind the scene. It basically captured, provisioned a lot of different things. You can see how it's still giving me some other recommendations that I can add more contracts to it. It's running. It's reading from the source and producing the data on that Snowflake output that we described. In this case, I didn't give it much logic in terms of the code. It was very simple, pretty much dump and drop a column. And it's producing the data live. And here we go. And it's very simple. This is just an off-the-shelf open source tool, and it only one setting I had to set. And the setting was the endpoint to the MCP gateway on the mesh that we provide out of the box. What this endpoint then provides is MCP tooling that the OS provides to you and the data product. For example, we can ask what data products are available. This is MCP tooling that our OS provides out of the box that tells you about all of the data products. So it's contemplating, it's working on it, and it's consulting that system data product. We have a few system data products that you don't see on the mesh. It belongs to the system. This gives you discovery information. We have 23 different data products on this mesh in different domains, and it's listing them, and I can see how our tutorial demo is also sneaking in there. And then I can see who has been accessing this data product over the last 7 days. Because every data product is sitting at the intersection of access, ingestion, control, all of that, we have very rich information that it looks like the sales and retail domain has been doing better than finance, and finance doesn't have as much activity as the other ones. We're gonna make that
fairly new.
Yeah, it's fairly new. So now let's ask the real business questions. Who are our competitors in terms of revenue? Now we are talking to the data products themselves. We're talking to financial statements in the demo environment, and we're getting the top revenue. And this data, some of it is true data, some of it is scrub data, some of it is synthetic data. So don't hold us accountable for correctness of the actual, numbers that you see. We try to be correct. And then ask about kind of the growth, right? We are interested in the net income growth of one of these companies in the last year. Let's say JB Hi-Fi was one of our competitors, and we ask about that. And in this case, now we are consulting the competitor growth analysis data product, and we're getting the growth from that. And it's providing, again, from the same semantic. Remember, I could ask these questions in a dashboard. From the same semantic, now I'm getting that information in a way that is relevant to the agentic technology. We designed Nextd to help you with the toughest, messiest data challenges, and that is inheriting a tangled hairball of legacy pipeline code built over time by many hands, scripts, data sets, different storage locations, and pipelines. Nextdata can analyze legacy code and data and design and build domain-oriented data products. Trying to turn legacy data processing code into a clean set of business domains and meaningful data products, That is often a long and expensive transformation project. So let's try another way with Nextd and start with the code base. A repo full of SQL scripts and ETL jobs. Let's get Nextd to analyze it. Okay, it's found an ETL code base with a medallion layered architecture in an e-commerce domain. It's found the source systems where the data comes from Amazon APIs, SAP, and others. It can tell us about the data sets and code in each layer, bronze, silver, gold. And these layers often have noticeable amounts of data and processing replication that are not directly adding value to business, but they add, to the cost of storage and compute. And Nextd has given us a simplified drawing of these layers to easily grok. The good news is that Nextd gives us a head start. We can understand what we're looking at, and now we're ready to change it. Now let's ask Nextd to think a little harder and recommend a set of business domains and data products. In other words, bootstrap our mesh of connected and well-bounded autonomous data products from 0 to 1. A first draft grounded in the actual code and data that we can shape, iterate on, and make our own. This removes the guesswork and helps us leap our transformation from a short and fast starting point. While Nextd is thinking, let me tell you what's happening under the hood. Nextd is actually a multi-agent system, and right now it's playing multiple roles at once. First, there's the mesh architect agent. It's been given context and prompts around best practices for identifying business domain boundaries and designing data products. And this part is art and science. And the one question that I get personally asked most often. There is the data products modeling agent. This agent looks at code and data consumption and knows how to create semantic models using Nextdata's framework. And at last, we have the data product coding implementation agent. And this one takes everything and rearranges the original code into clean, well-scoped data products. And finally, it adds quality checks, defined contracts, and writes the code and data product spec declarations. So while we wait, these agents are quietly doing the hard work, turning an unknown and messy repo and data into a clean, business-oriented, and connected mesh of autonomous data products. This may take a little while, so let's look at the progress again. It looks like it's producing the data products now. Great, it's done. All right, let's have a look at the data products and the domains it's modeled. Not bad at all. It's done a solid job. It's identified a set of distinct business domains like retail operations, product, vendors, and analytics. This last one is a bit suspicious. Analytics is not strictly a business domain. So let's take a note and we can review that later. Within each domain, it has identified a set of data products, source-aligned ones and aggregate ones that are derived from those. Well, this is a pretty smart starting point, and we can now iterate on with clarity. I personally love when my agent can explain why it's made these recommendations, so let's find out. Pretty comprehensible reasoning behind how it identified each business domain. And I love its reasoning for data product definitions to be focused on value and reusability. And another thing I really like is that V01 doesn't need to be perfect, but it needs to pave a clear migration path that then we can iterate on. And one more thing, it's fixing the disconnect between the technical names of tables and real business language by choosing business-oriented names and descriptions for the semantic model. This particular problem is currently solved by multiple tools, disconnected and cataloging steps that are done often manually by the business. That's the kind of trust and transparency we need in AI-driven development. Okay, now let's deep dive into one of these data products. Take vendor inventory. It tells us clearly which business domain it belongs to. It tells us that it aggregates data from Amazon and 7-Eleven sources. It describes its semantic model, both what it expects from upstream and the models that it produces for downstream. And wow, it's also telling us all about its code. That's a pretty long SQL statement. And the part I love, that it's created the quality contracts and the expectations on the input and promises on the output. And the best part, it spells out its dependencies to the original legacy code. I love this. Okay, I feel confident enough now to launch these autonomous, self-governing, self-orchestrating, independently managed data products. Let's bootstrap them. Nextd is giving us superpowers, and it is awesome. All right, let's move back to the Nextdata OS discovery experience. Here it is, our V01 version of our business domains and data products generated by Nextd. Clearly defined domains, vendor, retail operations, product. Well, analytics needs a review. Autonomous data products, who each manage their soup to nuts of data management locally, clearly imagined lineage about how data is consumed across boundaries of technology and data products on the mesh and off the mesh. And this is a solid starting point, and we can evolve from here.